topic that we are going to discuss is Bode plots. So Bode plot is a graphical method of analyzing stability of a system in frequency domain. So it is one of the graphical method like root locus, whereas root locus we analyze the stability of system in time domain, whereas with the help of this Bode plots we draw the graph and we analyze the stability of the system in frequency domain. So these Bode plots are two types: magnitude plot and phase angle plot. So combinedly, magnitude plot and phase angle plot are known as simply Bode plot. So for any system, either magnitude plot or phase angle plot are to be plotted. By combining magnitude plot and phase angle plot, we call those plots as Bode plot. So before going into the Bode plot, the Bode plots are drawn for sinusoidal transfer functions, and these plots are logarithmic plots. So the advantage of these plots is that as we are applying logarithm or we are taking logarithm of the magnitude of a transfer function while applying logarithm to a product, then what happens is in the logarithmic form the product will become into sums. That is what the advantage. It means the product of terms will be converted into sum of terms. This we see how the product of terms will be converted into sum of terms. Consider pole zero form of a transfer function. Here I am taking the open loop transfer function. So consider the pole zero form of a open loop transfer function. So I can write g of s into h of s is equal to some k into 1 plus st1 into 1 plus st2 so on 1 plus stm divided by s power r into 1 plus sta into 1 plus stb so on 1 plus stn into s square plus 2 zeta omega ns plus omega n square. Here we have 1 omega n. So this is the open loop transfer function of the system. The first step for drawing Bode plot is that you need to convert the open loop transfer function that is given in S domain into a sinusoidal transfer function. Initially, you need to convert the open loop transfer function given in S domain into a sinusoidal transfer. So you know that a sinusoidal transfer function is obtained from a transfer function that is expressed in S domain by substituting S is equal to j omega in the open loop transfer. So g of j omega into h of j omega is equal to omega n square into 1 plus j omega t1 into 1 plus j omega t2 so on 1 plus j omega tn into k divided by j omega power r into 1 plus j omega ta into 1 plus j omega tb so on 1 plus j omega tn into j omega square plus 2 zeta omega n into j omega plus omega n square. From this, we can write the magnitude of g of j omega into h of j omega as k into omega n square into square root of 1 plus omega square t1 square into 1 plus omega square t2 square into so on 1 plus omega square tm square divided by omega power r into square root of 1 plus omega square ts square into 1 plus under root 1 plus j omega square under root 1 plus omega square tb square so on under root 1 plus omega square tn. Similarly, we can write the phase angle. The phase angle of g of j omega into h of j omega is equal to tan inverse omega t1 plus tan inverse omega t2 plus so on plus tan inverse omega tm minus tan inverse omega ta minus tan inverse omega tb plus so on plus tan inverse omega tn minus this is minus tan inverse. Here this term will be equal to omega 2 zeta omega n into omega by omega n square minus omega square minus 90 into r. This is the phase angle. So as we change omega 0 to infinity, the values of modulus of g of j omega, h of j omega is going to change. And similarly, and also angle of g of j omega, h of j omega will also change. So the variation of modulus of g of j omega into h of j omega with omega on a logarithmic scale is known as magnitude plot. So the variation of modulus of g of j omega, h of j omega with omega on logarithmic scale is known as magnitude plot. So g of j omega, h of j omega is gain, and it do not have any units per gain. But while drawing the magnitude plot over a logarithmic scale, what we need to do is we need to take logarithm for the magnitude of g of j omega, h of j omega. So if you take logarithm to g of j omega and h of j omega to the base 10, then log to the base 10 g of j omega into h of j omega is equal to log of omega n square plus log to the base 10 k plus log to the base 10 under root 1 plus omega square t1 square plus log to the base 10 under root 1 plus omega square t2 square plus so on plus log to the base 10 under root 1 plus omega square tm. So these are the numerator terms. As you know that how I got these terms, you might be having a doubt. So you have the formula log to the base 10 AB is equal to log to the base 10 A plus log to the base 10 C. So logarithm of multiplication of two terms. If you take logarithm to multiplication of any two terms, then the logarithmic value will be added. So with the help of this formula, I have written this. Similarly, if you take division of two numbers, log to the base 10 a by b can be written as log to the base 10 a minus log b to the base 10. That means if it is a division, then it will become a difference. So you have n plus 2 terms in the denominator. These n plus 2 terms will become difference of with the numerator terms. So the denominator terms of modulus of g of j omega and h of j omega can be written as minus r into log omega minus log to the base 10 here also to the base 10 under root 1 plus omega square ta square minus log to the under root 1 plus to the base 10 1 plus omega square tb square minus so on minus log to the base 10 square root of omega n minus omega square plus 2 zeta omega n into omega whole square. So this is the logarithm to the base 10. So we need to convert this into decibels. So 1 decibel is equal to 20 log 10 into 20 log 10 of the gain. So to convert all these factors into decibels, you multiply the left hand terms with the 20, left hand side terms with 20 and right hand side terms with 20, so that the entire gain is expressed in decibels. So expressing the gain in decibels. 20 log to the base 10 modulus of g of j omega into h of j omega is equal to 20 log to the base 10 omega m square 20 log to the base 10 k plus 20 log to the base 10 under root 1 plus omega square t1 square. Just I am taking only one term. So on minus 20 into r log omega to the base 10 minus 20 log to the base 10 square root of 1 square plus omega square t square minus so on minus 20 log to the base 10 under root omega n minus omega square plus 2 zeta omega n into omega square. So these are the terms. So if you observe the terms, we are having different terms. One is 20 log k to the base 10. Another one is 20 log 10 under root 1 plus omega square t1 square. Another one is 20 into r log 10 omega, and another term is 20 log 10 under root omega minus omega square plus 2 zeta omega n omega square. So these are the four terms. If you can draw Bode magnitude plot for all these four terms, then remaining terms are similar to these terms. Remaining terms are similar to these terms. So that it would be very easier for you to draw the entire Bode magnitude plot for any kind of transfer function. What you need to do is just you need to add all the gains of the different factors in logarithmic scale. Okay. Now coming to the magnitude plot. If omega is varied, then the phase angle of g of j omega, h of j omega is also change. So phase angle plot is the plot that was drawn omega against g of j omega into h of j omega. So this plot is known as phase angle plot. So if you observe the phase angle values, so these are the phase angle values of g of j omega into h of j omega. These are also sum and difference of different factors whose tan inverse value is taken for plotting. Okay. Now we see how to plot Bode magnitude plot for different factors. So first we start with 20 log k to the base 10. Magnitude and phase angle plot for g of s is equal to k, g of s into h of s. So the open loop transfer function g of s into h of s is equal to k. For this, we need to draw the magnitude and phase angle plot. Before drawing the magnitude and phase angle plot, we define decade frequency. 10. Decade means 10. So what is a decade frequency? So we have a frequency omega, right? So if you multiply this omega with 10, you will get 10 omega. So this 10 omega is known as the decade frequency. So here you need to remember this. Decade frequency is the frequency of a given frequency. So the decade frequency of a given frequency is obtained by multiplying the given frequency with 10. For example, omega is equal to 10 radians per second. So what is its decade frequency? 10 into 10. That is equal to 100 radians per second is the decade frequency of 10. Now you tell me, what is the decade frequency of 100? Decade frequency of 100. You multiply this 100 with 10. 100 with 10 will become 1000. So 1000 is the decade frequency of 100. Similarly, what is the decade frequency of 1000? 10,000. What is the decade frequency of 10,000? 1 lakh. So if you multiply a given frequency with 10, you will get a new frequency. That new frequency is known as decade frequency of given frequency. Okay. So we need to draw the magnitude plot and phase angle plot for g of s into h of s is equal to k. So what is the first step? Convert g of s into h of s. So you convert g of s into h of s into sinusoidal transform. This is what the first step. This can be done by substituting s is equal to j omega in g of s into h of. So g of j omega into h of j omega is equal to k. This k is known as the gain. This k value is known as gain. So which is always a positive value. So now you find out the magnitude of g of j omega into h of j omega. It is a positive and real value. K is positive and real. So under root k square plus imaginary value is not there, 0 square, which is equal to k. Right? Now 20 log to the base 10 g of j omega into h of j omega is equal to 20 log 10 k, and modulus of g of j omega into h of j omega is equal to tan inverse 0 by k. There is no imaginary value, which is equal to 0 degree. So the magnitude, if you draw the magnitude plot, omega 20 log to the base 10 k, and the phase angle is 0 degree. When omega is equal to 1 radian per second, its value is equal to 20 log 10 k, and phase angle is 0 degree. Coming to the another value of omega, we assume that we are changing the omega in decades. So the decade frequency of omega is equal to 1 is 10. Okay. So here there is no omega term is present in 20 log 10. Its value is not going to change. It will remain constant at 20 log k to the base 10, and the phase angle also does not change. Now you take decade frequency of 10. The decade frequency of 10 is 100. Now you write the value 20 log k to the base 10, which is equal to 20 log 10 k, 20 log k to the base 10, and the phase angle is also equal to 0. Now you take the decade frequency of 100, which is equal to 1000. Here also the value is 20 log k to the base 10, and the phase angle is 0. Now you take the decade frequency of 1000, which is 10,000. The magnitude is 20 log k to the base 10, and the phase angle is 0. So from this what we can say is the magnitude of g of j omega is constant irrespective of the frequency. So if you draw the magnitude plot by taking omega values on x-axis 1, 10, 100, 1000, 10,000, as omega is increasing like this, and gain on y-axis, gain in dB, decibels. Here somewhere you can find 20 log k to the base 10. This value is constant throughout the change in omega. So this is the magnitude plot. Coming to the phase angle plot. The phase angle plot, this is 0 degrees plot. Somewhere here you can find plus 90 degrees. Somewhere here you can find minus 90 degrees. So this is omega is equal to 1, omega is equal to 10, omega is equal to 100, omega is equal to 1000, omega is equal to 10,000. So this value will remain at 0. So from this what we can say that the magnitude plot of a constant term, the magnitude plot of g of s into h of s is equal to k is a straight line having a constant magnitude of equal to 20 log k to the base 10 to base 10, and the phase angle plot is also a line, straight line having a constant value equal to 0 degrees. So we know what is the shape of the magnitude plot and phase angle plot for this kind of factor. So I stop here for today. మనకి రెండు రకాల ఫ్యాక్టర్స్ ఉంటాయి ఇక్కడ. ఏంటంటే 1 plus j omega t లేదా 1 plus j omega t or 1 by 1 plus j omega t. దీన్ని మనం ఎలా రాయొచ్చు అంటే ఈ రెండింటిని మనం ఎలా రిప్రజెంట్ చేయొచ్చు అంటే 1 plus j omega t whole power plus or minus 1. సో ఇది ప్లస్ 1 అవుతుంది. దిస్ ఇస్ ఈక్వల్ టు 1 plus j omega t minus 1 అవుతుంది. ఓకే, సో ఈ రకమైన ఫ్యాక్టర్స్ ఉంటే బొడే మ్యాగ్నిట్యూడ్ ప్లాట్, ఫేజ్ యాంగిల్ ప్లాట్ ఎలా డ్రా చేస్తాము అన్నది చూద్దాం. ఓకే, సో ఫస్ట్ వి కన్సిడర్ ది ఫ్యాక్టర్. కన్సిడర్ g of s into h of s is equal to 1 plus s tau. The sinusoidal transfer function we need to write. Sinusoidal transfer function of the system. G of j omega into h of j omega is equal to 1 plus j omega t. So modulus of g of j omega into h of j omega is equal to square root of 1 plus omega square t square. And the phase angle of g of j omega h of j omega is equal to tan inverse omega t. So here the magnitude plot for this kind of factor is divided into two parts. In the first part, we consider that omega t is less than, much more less than 1. So if omega t value is considerably less than 1, then omega square t square is also less than 1, and it can be neglected and is approximated equal to 0. So for low frequencies, that is omega t value much more less than 1, then omega square t square is equal to 0. So modulus of g of j omega h of j omega is equal to 1. For high frequencies, that is omega t is much more greater than 1, then omega square t square is much more greater than 1. In such cases, 1 plus omega square t square is taken equal to omega square and t square. So modulus of g of j omega h of j omega is equal to under root omega square t square is equal to omega t. Here, at what value we need to take omega t values are much more less than 1 and omega t values are greater than 1. Here, we define corner frequency. So the corner frequency is defined as that value of omega where omega into t is equal to 1. So it is the value of omega where omega into t is equal to 1. So this is denoted by omega c. So omega c is equal to 1 by t. That means if omega value is equal to omega c, that is equal to 1 by t, then omega into t is equal to 1. So that means for omega values less than omega c, modulus of g of j omega into h of j omega is equal to 1. For omega greater than omega c, modulus of g of j omega h of j omega is equal to omega t. Okay. Now we try to find out the gain value in decibels. So 20 log modulus of g of j omega h of j omega is equal to 20 log, here to the base 10 we need to take, to the base 10 1. This is for omega less than omega c. 20 log 10 modulus of g of j omega h of j omega is equal to 0. Because you know that logarithm of 1 is 0, logarithm of 1 to the base 10 is 0, 20 into 0 is equal to 0. So for omega less than omega c, the magnitude plot is 0 dB line. Okay. Now we see what is the value for omega greater than omega c. For omega greater than omega c, modulus of g of j omega into h of j omega is equal to omega t. So now we find out this gain value in decibels. So 20 log 10 modulus of g of j omega h of j omega is equal to 20 log 10 omega t. Now we see what is the value. Here we assume that at omega t we calculate 20 log 10 g of j omega h of j omega value at omega is equal to omega c. So what is the value of omega c? Omega c is equal to 1 by t. So by doing so, we will get this value as 20 log 10 into 1 by t into t. T will get cancelled, 1 remains left. So 20 log 10, 1. You know that 20 log 10, 1 is equal to 0. So yet omega is equal to omega c, that is equal to 1 by t. 1 by t, 20 log to the base 10 g of j omega h of j omega is equal to 0. Again, we calculate the gain value at the decade frequency of this omega c. So what is the decade frequency of omega c? You need to multiply this omega c value with 10. So 10 omega c will become the decade frequency value of omega c is equal to 10 by t. Now, the value of gain at 10 omega c is omega is equal to 10 omega c is equal to 20 log 10, 10 by t into t. Tt will get cancelled. We are left with 20 log 10 to the base 10. Log 10 to the base equal to 1. So 20 into 1 will become 20. So the value of 20 log to the base 10 modulus of g of j omega h of j omega at omega is equal to 10 omega c is equal to 20 decibels. Now we calculate the value of 20 log 10 g of j omega h of j omega at frequency omega is equal to decade frequency of 10 omega c. So the decade frequency of 10 omega c is 10 multiplied with 10 omega c, whose value is equal to 100 omega c. So at omega is equal to 100 omega c, 20 log 10 g of j omega into h of j omega is equal to omega is equal to 100 omega c is equal to 20 log 10 100 by t is equal to 100 by t, this value, into t. Tt will get cancelled, which is equal to 20 log 100 to the base 10. So log 100 to the base 10 is equal to 2. So this value is equal to 40 dB. So if you draw the magnitude plot, somewhere here you will find omega c is equal to omega t. Here 10 omega c, that is equal to 10 by t, and here 100 omega c, that is equal to 100 by t. And this is the value 0.1 omega c, that is equal to 0.1 by t. So these are the values that are less than omega c, and these are the values that are greater than omega c. So for omega values less than omega c, it is a straight line having a gain of 0 dB. So this is the 0 dB line. Here I am taken 20 dB and 40 dB and 60 dB. So its magnitude is equal to 0 at omega c is equal to 1 by t. When omega value is equal to 10 omega c, the magnitude is equal to 20 dB. When omega value is equal to 100 omega c, this magnitude value is equal to 60 dB. So you join these lines, these points. So we join these points. Okay. So like this, you will get straight lines. Okay. So and this line will be extended like this. So this is a straight line having a slope of 20 decibels per decade. So here this is the magnitude of 1 plus j omega t at omega is equal to omega c, and this is the magnitude of g of j omega and h of j omega at omega c is equal to 1 by t, and this is the magnitude. The value is 20 dB at omega is equal to 10 omega c. So you know that this is the decade frequency of omega c. So if you observe the gain is having a change of 20 decibels per decade. You know how to calculate change. Highest frequency value, gain at highest frequency minus gain at the lowest frequency. So divided by the frequency value. So the frequency change is 1 decade. So change in gain is 20 minus 0, that is equal to 20 dB. So the magnitude plot of 1 plus j omega t is a straight line. The magnitude plot of 1 plus j omega t is a straight line for omega greater than omega c and have a slope of 20 decibels per decade. So the magnitude plot of 1 plus j omega t is divided into two parts. One part is omega values less than omega c. The second part is for omega values greater than omega c. So what is the value of omega c? Omega c is equal to 1 by t. So the t value is given to you in the transfer function itself. So that omega is equal to 1 by t is known as corner frequency. So for frequency values less than the corner frequency, the magnitude plot is 0 dB. The magnitude of g of j omega H of j omega is 0 decibels. For frequencies higher than omega c, then the magnitude plot is a straight line having a slope of 20 decibels per decade. If you are given with a factor like this, then the magnitude plot for this factor is for omega less than omega c, the magnitude plot is a 0 dB line. Next, for omega greater than or equal to omega c, the magnitude plot is a straight line having a slope of 2 into 20 dB per decade, that is equal to 40 dB per decade. So if you are having a factor like this, 1 plus j omega t whole power r, then the magnitude plot is for omega less than omega c, the magnitude plot is 0 dB line, and for omega greater than or equal to omega c, the magnitude plot is a straight line with slope 20 into r dB per decade. So this point you need to remember. So if r is equal to minus 1, then the factor is 1 plus j omega t whole power minus 1 is equal to 1 by 1 plus j omega t. Then the magnitude plot is a straight line with slope minus 20 dB per decade for omega greater than or equal to omega c, and for omega less than omega c, it is 0 dB. Similarly, if you are having multiple poles at omega is equal to 1 by t minus, then the magnitude plot is minus 40 dB per decade for omega greater than or equal to omega c, and is 0 dB for omega less than omega c. So this is how you can find out the magnitude plots for different factors. Okay. So if you prepare the concepts of root locus, Bode plot, there is a possibility that you can gain 30 out of 30 in the examination. So these are the simplest ways of securing marks in the examination.